Okie doke. We're going to kind of stay in the geometry realm, and we're going to talk about parallel lines cut by transversals. Biggest things you need to know. When you have two parallel lines, and you can tell they're parallel lines because they will have marks, or that might be an L, and that might be an N, and they'll say L is parallel to N. And they're going to be cut by a transversal. That transversal, they might call it T. And then they might number these angles. 1, 2, 3, 4, 5, 6, 7, and 8. What you need to know is the different theorems that you get from the parallel lines cut by the transversals. And what angles are going to be equal to each other. Well, the measure of angle 1 is equal to the measure of angle 5. Or you could say that angle 1 is congruent to angle 5. And I'll say, we'll just go with congruency with this. And these are what we call corresponding angles. Angles that are in the same location. 1 and 5. If I were to cut this entire intersection, pick it up and put it right on top of there, angle 1 would be right on top of angle 5. Angle 2 would be right on top of angle 6. So angle 2 would be congruent to angle 6. And they'd be corresponding. And I'll put 2 arcs for them. Now, through vertical angles, angle 1 is congruent to angle 4. And angle 4 is corresponding with angle 8. So angle 4 is congruent to angle 8. And the same rationale here, angle 3 is congruent to angle 7 because they're corresponding. Now, there's some other pairs of angles. Let me zoom out a little bit so I have a little bit more space to work. Angle 1 and 8, these are alternate exterior angles. Angle 1 is congruent to angle 8, 1 and 8, and 2 and 5. Angle 2 is congruent to angle, not 5, but angle 7. Now, when you hear alternate, you're going to jump over the transversal. So you're on the alternate side of the transversal. And if you're in the exterior, you're going to alternate basically your position. You're in the top left. Then you're going to switch over to the top right, and then you're going to go to the bottom right. So you're going to alternate both positions twice. Same thing here. If you're in the top right, you go to the top left, and then you go to the bottom left. There's alternate interior angles. Same thing. Look at angle 4. Angle 4 is in the top right of the interior. This is the interior. Between the two lines. Everything else is the exterior. If I'm going to alternate this angle, do the alternate of this angle, I have to go from the top right to the top left, and then I go from the top to the bottom. So angle 5 and angle 4 are alternate. Angle 4 is congruent to angle 5, and if I stick with 3, I'm in the top left, I go to the top right, and then I go to the bottom right. So I have angle 3 is congruent to angle 6. And the last one, same side, interior angles are supplementary, which means they add up. Their sum is equal to 180 degrees. So the same side right here, the same side, measure of angle 3 plus the measure of angle 5 is equal to 180 degrees. Measure of angle 4 plus measure of angle 6 is equal to 180 degrees. Now, big thing with this, in order to solve this, think of linear pairs. And those are two angles that, like 1 and 2, like this, that form, they're adjacent to each other and they form a straight line. Measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. Think of vertical angles. That's like angle 1 and 2, and I could say angle 1 is congruent to angle 2 because vertical angles are congruent. And we can use that, all those ideas, to kind of build this situation from here. Now, on our master, we can sort of draw two parallel lines. Let me move this up a little bit farther and zoom in just a little bit. Draw two parallel lines. Don't want to make it too big. 1, 2, 3, 4, 5, 6, 7, 8. Make sure they're